Hey y'all, this lesson is for completing the square, and we use this when we are trying to solve quadratic equations, or you can use it to put a quadratic equation in vertex form and find the vertex. So completing the square comes in handy when maybe you can't solve a quadratic by factoring or using the square root property. And so I will show you that today in this lesson. In my previous video, I showed you how to solve a quadratic using the square root property. And that works really well when a trinomial can be factored using the perfect square trinomial little trick or whatever. So just an example of that I have up here. It might look like this to start. And so this had been a perfect square trinomial that was factored, and then we can use the square root property to solve for x. Well, today we're going to be looking at situations where the quadratic can't be factored because it's maybe not factorable or even not a perfect square trinomial. So perfect square trinomials look like this, where the first term is a perfect square, the second term is a perfect square, and the middle term is 2 times the square root of both the first and third. Sorry, I think I said second term, meant third terms. So that's not the focus of today's lesson, but that's just kind of the pattern of a perfect square trinomial. And those perfect square trinomials can be factored easily into this. So just a quick example of that to kind of show you what you would be looking for if you did have a perfect square trinomial. I have two examples down here. The first one is x squared minus 6x plus 9. So 9 is a perfect square. X squared is a perfect square. And if we take the square root of 1 and 9, that'd be 1 and 3, and we double it, that makes 6 our middle term. So this follows the perfect square trinomial pattern. And then to factor it, it factors into x minus 3 times x minus 3, which translates into x minus 3 squared. And that's a perfect square trinomial. And if we had it set equal to 0 or some number, then we could square root both sides and solve for x easily. And then another example of a perfect square trinomial, 4x is a perfect square, or 4x squared is a perfect square, 25 is a perfect square. Double the square root of both is going to get you this middle term. So it follows the pattern, which means that we can factor it into 2x plus 5 squared. And then we would square root both sides, solve for x, done, super simple. So when a trinomial is not a perfect square, we can manipulate the equation to complete the square, and that's where completing the square comes in handy. So we're literally moving stuff around to make it look like a situation like this where we already know how to solve. So a couple examples, we have a missing piece basically, and we're trying to find the C value that makes this trinomial a perfect square. And one of the ways to do that without having to memorize a formula, I like formulas, they work for me, but just to kind of show you where the formula comes from, I'm going to use the box method. And basically what's going to happen here is if I were to break up negative 4x, I'm sorry, I'm going to put x squared here. And if I were to break up negative 4x evenly, like half it, that would be negative 2x and negative 2x. So when I add those, negative 2x minus 2x makes negative 4x. I've split it up evenly because I'm trying to get it to follow this pattern. then if I were to complete this square, I have a square, it's kind of a rectangle in this case, but I have a square. I'm trying to find the C value that's going to complete this. So if I were to factor this, then on the outside, when I factor this column, they have a GCF of X. And then this column has a GCF of X. And then if I were to guess about the GCF of this row, I would guess -2 and -2. And then the product of those is 4. So the missing piece is 4. What that means is that's the piece that makes this a perfect square trinomial. So if I had x squared minus 4x plus 4, I could factor that into x minus 2 times x minus 2, which is x minus 2 squared. So what happened was I took half of this and split it into 2 boxes, and that became the value inside my factored form. Let's look at one more, just to kind of solidify this in our minds. We've got a box. We know that x squared is going to go here. We're going to break up -10x evenly. And then if we were to factor that, we would have an x here, an x here, a -5 here, a -5 here, and 25 would be our missing piece because of this times this. So my perfect square trinomial now is x squared minus 10x plus 25, which factors into x minus 5 times x minus 5, which simplifies to x minus 5 squared. So we're trying to find a C value that makes this incomplete square complete. And this will all make sense in a second when we get into actually completing this, solving by completing the square. So the C value, we know that the C value in both cases is a perfect square because we're taking half of the middle term and multiplying them together. And anything times itself is a square. So we took half of the middle term, which is b, and multiplied it by itself, which is squared. So we could put that in symbolic form and say C is half of B, and then we squared it, right? So let's look back. Let's just take a look, see if it checks out. Half of B is -2. -2 squared is +4, because anything squared is positive. That worked. Half of B is -5. -5 squared is +25. So instead of having to do this box every single time, what's happening is we're splitting that B value up into 2 pieces, and then we're multiplying those 2 pieces together. So B over 2, splitting them up, squared to find the C value. And that brings us to our formula. Isn't that neat? So hopefully the box kind of helps you picture the splitting up, B over 2, we're having it. And then we multiplied those 2 pieces together, we're squaring it to find the C value, which completes the square and makes a perfect square trinomial. Isn't that so neat? I love math. So we're going to use completing the square to solve equations. Now, usually you'll have a trinomial, and what you'll want to do is, actually, I'll start with this example. I'm going to start with number 6. So we have a trinomial, and while this is a perfect square and this is a perfect square, when I do double the square roots of each, I'm not going to get 4. So this is not factorable. There are no factors of 1 that add to 4, which means that I'm going to have to do some stuff to make it factorable. And basically what you're going to do is you're going to move this C value away. I want to move it. I don't like it. I can't necessarily just get rid of it, but I can move it aside for the time being. And now I have x squared plus 4x. I need a new C value, but I can't just add that C value to one side. I have to add it to both to make it balanced. I'm actually going to do this in a different color. And we want to find a C value that makes this side factorable. And we just learned how to do it. So now we can. We know that C is b over 2 squared. 4 over 2 is 2. Squared is 4. So now I have a trinomial, a perfect square trinomial, because I made it that way, set equal to -1 plus 4 is 3. Now that I've completed the square on the left side and made it a perfect square, I know that it's going to factor into x plus 2 times x plus 2, which simplifies to x plus 2 squared. And then the goal of this one is to solve. So my next step is to isolate x. And in order to do that, I'm going to be using my square root property from my previous video. And I'm going to square root both sides. Again, I didn't give myself enough room here. Always a problem with me because I need this plus or minus here. Since remember, when you square something, it could have been negative or it could have been positive. So we have both cases. The x plus 2 gets to come out, and then we have plus or minus square root 3. 3 is prime, so I can't simplify it. And then I'm going to subtract 2 from both sides, and we get -2 plus or minus square root 3. And that's it. Those are your two x-intercepts of this function. So if I were to graph this function, it would cross at -2 minus square root 3 and -2 plus square root 3. Those are two different solutions, so we put them in solution set, not a parentheses. A parentheses is going to indicate either an interval or a point. This is not 1 point, this is 2 points. So we use solution set. And then if you're graphing, I would recommend going ahead and putting this in decimal form. And to do that, you're going to have to put each one in separately. -2 minus second x squared 3, and then -2 plus second x squared 3. And those are the two x-intercepts. These are decimal answers, which are approximations of the x-intercepts. The decimal answers are not exact solutions. So if a question is asking for an exact solution, it wants the solution with the square root. But as far as like if you're graphing, that's going to be a little hard to graph with a square root because you're like, where even is that? So you can approximate it with the decimal if you're graphing. We get -3.73 and -0.27. So this is about -3.73 and -0.27. And that's it. That's all it wants. So let's go back up to the example above. We have x squared plus 6x equals 7. Now, the c-value has already been moved over to the right side, and it is not a perfect square, so I don't want to bother moving it over to the other side. So I need to find a c-value. I should do a different color. To make this a perfect square. And you might be looking at this and think, oh, there's a different method to solve this. And you may be right. But for the sake of this lesson, I'm wanting to practice completing the square. So I have to find my new c value, which means I'm going to do half of b and square it, which is 9. So 9 goes on both sides. And I will say it is so important. You might think that's kind of a tedious, unnecessary step, but it is such a good reminder to put those blanks on both sides of the equation so that you don't forget. Because so often when you're just moving really quickly and doing a problem and you're not paying attention, you'll just add it to one side. And then now your equation's unbalanced and your answer is just going to be wrong. So please make sure you put it on both sides. And then we have on the left side, we have our perfect square trinomial because we have completed the square by finding the new c value. We will factor it and then add the right side, simplify the right side. So we have x plus 3 squared equals 16. Square root both sides. And we get x plus 3 equals plus or minus square root of 16 is 4. Then we're going to subtract 3. I usually put whatever I've moved over in front of the plus or minus because it just makes more sense to my mind. With the commutative property, you can put it behind the 4, but I just feel like it makes more sense to have that plus or minus in the middle. Because now what we have is two solutions, -3 plus 4 and -3 minus 4, which is 1 and -7. So my two x-intercepts are -7 and 1. That means that if I were to graph this function, the original function, it would cross the x-axis at -7 and 1. And you might have to write those as points. And that's how you would do that. So that one was nice. That one turned out really nice. I like those. Now let's look at number 7. If you can, I want you to pause the video and at least get it started. If you get stuck, then hit play and watch what I do. But try to do this one on your own and then come back and check your work. So hopefully if you did it on your own, you moved the 5 over by adding it. And then you're looking for your new c value. Now this one doesn't turn out as nicely as the first two examples. We're going to end up with a fraction, which is okay. Trust me, it ends up being okay. We're doing half of b squared, and -3 doesn't divide by 2 evenly, so it's kind of a bummer. But trust me, it works out. I am going to keep this in fraction form, and I'll show you why in a second. -3 squared is 9, 2 squared is 4, so my new c value is 9/4. And then you might get stuck here. You might go, oh my gosh, I don't know how to factor with fractions. That's so scary. I can't do it, but you can do it. It's not scary. We know from the previous examples that whatever we got right here goes in our factored form. b over 2 goes in our factored form in every case. So we don't have to worry about, oh no, I got to find factors of 9/4 that add to -3. you've already found it. You've already found the factor. It's right here. So we factor it into x minus 3 halves squared equals 5 plus 9 fourths. Again, you might be stuck. Don't worry. If you have a calculator, you can do it in your calculator and then do math, enter, enter to get it in fraction form. I'm going to do it by hand. I need a common denominator of 4, so that's going to be 20 over 4 plus 9 over 4. Should have given myself some more room, but that's okay. And then that's going to be 29 over 4. And if you have decimals, I would just recommend doing fractions, because in this next step, when I square root both sides, whoops, what's going to happen here is x minus 3 halves comes out, and then I have square root 29 over square root 4, which is 2. And then when I move 3 halves over, I'm going to add it. Now I have a common denominator, which is really nice because I'm going to consolidate my answer with 3 plus or minus square root 29 all over 2. And that's my solution. So you can kind of see how the fractions end up kind of helping you in the end. When we square root, we end up getting common denominators, makes it really simple to add, especially, this one kind of turned out yucky, but especially if this had been a perfect square, then we could have simplified it even further. But since 29 is prime, I'm just kind of done there. You could find the decimal answers. It may want, in your homework, it may want the 2 separate answers of 3 minus square root 29 over 2 and 3 plus square root 29 over 2. That's fine. You can also find the decimal answers of those and round. That would be fine. But if you leave it in fraction form, then you end up with this nice, neat, exact solution. And these exact solutions are really important, especially if you're going on in higher mathematics. You're going to need those exact solutions. So last one here. I'll zoom out a little bit so you can see that. We have a coefficient on our trinomial. So what you're going to do is factor out that coefficient. It looks like I'm going to need a little bit more room for this problem, so I'm going to go over here to some blank paper. And like I mentioned, we are going to have to factor out the 2 first, but before I factor out 2, I'm actually going to move the 1 over. It's just going to make it a little bit easier so we don't have to deal with so many fractions in the process. So I'm going to move 1 over. I'm looking for a new C value, goes on both sides. And then I'm going to factor out this 2. And I still have this C value. But what's different here is now my C value actually has this 2. It's kind of hidden being multiplied by it. So this is 2x squared. Whoops, made a mistake here. That would have been bad. Glad I went back. Minus 4x plus 2 times something. So my C value is actually 2 times something. So when you have a coefficient on this for completing, on the trinomial for completing the square, and you take out that coefficient, your C value has that with it. So you cannot forget it. If you forget it, your answer is going to be wrong. So make sure that if you factor out your coefficient, that you put it back in on the other side. So now I'm going to go about my process in the same exact way that I have been on previous examples. I am now trying to complete this square with what's inside the parentheses. So I'm doing half of b squared, which is -1 squared, which is 1. So that's what goes on both sides. And now I'm going to factor what's inside the parentheses. So I've got my 2 outside. I know this factors into x minus half of b squared. And then 1 plus 2 times 1 is 3. Which at this point, this should look familiar. When we did solve by the square root property, we know exactly how to do this. So now we've gotten to a point that we can confidently complete the problem. We're going to isolate x by dividing by 2. So we have x minus 1 squared equals 3 halves. Left myself room this time. Square root both sides. And we have x minus 1 equals plus or minus square root of 3 halves. And then I'm going to add 1 plus or minus square root 3 halves. Now this right here is not simplified. So I need to do a little bit of side work to get it that way. So I'm going to go over here. This breaks it down into square root 3 over square root 2. For something to be simplified, you can't have a square root in the denominator, so I'm going to remedy that. And we end up with square root 6 over square root 4. Square root 4 is 2. Which means I'm going to rewrite this as square root 6 over 2. And I have my two solutions. I have 1 minus square root 6 over 2 and 1 plus square root 6 over 2. And that's it. So this one was a little bit more involved because of the coefficient, but the only added step really is to factor out that coefficient and then make sure you have it on the other side. And then all the rest of the steps are the same. Ideally, this would have simplified perfectly, but it didn't. And I'm kind of glad it didn't because I got a chance to show you how to simplify square roots. So if you didn't have that skill before, hopefully this little side note's going to help you with that. But that's all it is. I would recommend on problems like this, making sure you can see that this took up an entire sheet of paper. And maybe it didn't have to, but I will say, as you learn mathematics and as mathematics takes more and more steps to solve something, I would definitely recommend just embracing using paper, or using, this isn't real paper, it's virtual paper, but just embrace that. Add pieces of paper to your notes, have notebook paper beside you, or have in this is my Good Notes app. I have a notebook of blank paper and I just keep it open in the tabs. And so I can easily switch to the blank paper and use it if I need to write out my thought processes or just have a little bit more space to think. So back here in my notes, I only had this little tiny space, and I got a little stressed out by not having enough space to work out my problem. So I would definitely recommend having that extra notebook paper, or having the extra notebook in your app that you can go to for blank paper. And then now I can go back here and just rewrite my solutions. And then if you were wanting the decimal representation of those exact solutions, you could go to your calculator. We've got 1 minus, I'm going to do a parentheses here to show my calculator that this is a fraction. Second x squared 6, arrow out of that, over 2. So you can see that in mine, the square root symbol has stopped. and then I'm dividing by 2. I don't want the divided by 2 to be in the square root because it's not in the square root. And then I did do another parentheses to show that I'm closing this fraction. Now you may have a fraction function in your calculator that sets up this template where it's like numerator, denominator, which is really nice. But mine doesn't, so I have to tell my calculator that this is a fraction. And then I'll do the same thing for 1 plus parentheses second x squared 6, get out of the x squared or the square root, divided by 2, close it, and there's the other one. So there's your decimals for that. That is all for completing the square, but there's more. But wait, there's more. If we go back to my notes on vertex, then you might recall that vertex form of a quadratic is y equals a times x minus h squared plus k, where the vertex was hk. When we use completing the square, we're finding vertex form. So when you have a quadratic that is in standard form or even factored form, you can find the vertex by using the vertex formula or converting to vertex form, which is kind of nice. So now we have this new skill that we call completing the square, and completing the square can help us find two things: the x-intercepts and the vertex. So it's really nice. It's oftentimes students hate completing the square, but if you can get confident with it, then by completing the square, you can find two things at once. So it's pretty nice. I like completing the square. I think it's kind of fun. It does get a little tedious with the coefficient or the square roots, but once you become confident in those skills, then it is a really nice thing to know how to do. So let's practice that a little bit. Write the function in vertex form. So when it says write the function in vertex form, it's asking you to complete the square. And in this particular problem, the C value is already moved over. It is not a perfect square, so I'm going to leave it over there. I don't want to mess with it. I'm going to leave it. And my goal is to find the new C value that makes this a perfect square, which we already know how to do. 4 over 2 squared is 4. Then I'm going to factor the right or left side, sorry. Now, stop right here. In the previous examples when we were solving, we square root both sides and solve for x. But one little difference is we're not solving. We're asking for vertex form. And vertex form has everything on the same side. So now instead of square rooting both sides, I'm going to move 16 over. And instead of equal to 0, I'm going to have y equals x plus 2 squared minus 16. And that is vertex form. It's not asking you to solve. If it were asking you for the x-intercepts, then you would solve, but it's asking for vertex form. So what it wants is for you to complete the square and then move everything on the same side. And from vertex form, we can see the vertex. In this case is -2, -16. And the axis of symmetry is x equals -2. Now, I kind of went over that quickly because I already did a video on vertex form. So if you got lost there, you might go back and reference that. But I'm using this general form to help me find this here. So in summary, we need to, if we need to find the vertex, or sorry, we can use completing the square when we need to find the vertex or the axis of symmetry. And we can also use completing the square when the equation cannot be solved by factoring. So that is all for completing the square. I hope you enjoyed it. If you have any questions, please let me know and I would be happy to help. See y'all in the next one.